Let's explore rational exponents. We want to define the power a to the rational number m over n. Let's explore an example. 4 to the 3/2 power. What do we mean by that? Let's look at two ways of looking at this. First, let's take 4 and cube it, and then take the square root of the result. What we get is, let's see, 4 cubed, 64, and the square root of 64 is positive 8. Now let's reverse the order. Let's first take the square root of 4, and then let's cube that result. Square root of 4 is 2. 2 cubed is positive 8. We get the same result each way. That leads us to define a to the m over m as either, we have a choice here. It's the same as a to the m followed by the nth root, or the nth root of a all to the nth power. This is, let's make this note, we need the nth root of a to be defined as a real number. And we also always start, we talk about this with a rational number in lowest terms. Let's do an example. Let's simplify this expression. So we see from the definition that we have two ways of doing this. We can start by taking the square root, then following that with the power negative 3, or we can start with that power of negative 3 inside, and then take the square root of that result. Let's go through the second way. 16 to the negative 3. It's the same as 1 over the cube of 16. There's laws of exponents. And then, this is this computation. 16 cubed turns out to be 4,096. So we now need to take the square root of 1 over 4,096. So let's stop right there. You can keep on going and get the answer. Let's see what happens this way. The square root of 16, positive 4, to the negative third power. And laws of exponents, 1 over 4 cubed. 4 cubed is 64. So here's our final answer. This rational number, which is our final answer because it's in lowest terms. So we see that this was this way right here, as you'll see in a number of these problems. It's far more superior to the other way. Let's do another example with rational exponents. Let's simplify this expression. And it turns out that the laws of exponents are valid for integer exponents as well as rational number exponents. Great. So what do we want to do first? First, we want to distribute the power 3/2. Here's one way to do this problem. Start by distributing 3/2. So the 3/2 power gets distributed to each factor inside the parentheses. 4 to the 3/2 times x to the minus 1 all raised to 3/2 times y to the 1/3 all to the positive 3/2. And on the bottom we get x to the 3/2 times y to the 3/2. Okay. So now we see that if you take we have the rule, the law, that division of powers with the same base can be simplified into just one power. So we would like to do that here, right? We have base of x here and here, base of y here and here. So we would like to apply this law. First, let's see. This isn't exactly x to a number. It's x to a power, all raised to a power. So to get it in this form, x to just a single power, we can use the law that says that this is negative 1 times 3/2, negative 3/2. And for the y, the numerator, this would just simply be y to the product. 1/3 times 3/2 is 1/2. This is 4 to the 3/2. We have 4 to the 3/2. Separate these into 3 fractions, or 3 factors. This factor, this will be a fraction. It's x to the minus 3/2, x to the positive 3/2. Here, y to the 1/2, y to the 3/2. Okay. So let's compute 4 to the 3/2 power. Okay, let's write it right here. To the 3/2. Try the square root of 4 all cubed. It's 2 cubed, which is 8. We didn't do this over here. So this is 8. And by this law right here, this law, this becomes x to this power, and this becomes y to this power. Almost finished. Again, we need this fully simplified. So this becomes x to the power minus 3, y to the power minus 1. And since the directions say only positive exponents are our final answer, we have to make those 2 exponents positive. So 8 over x cubed y. Very final answer.